transform in the beginning because already we have studied Fourier series, and related to that our first section contents we have finished. Now from second section we have Z transform, Laplace transform, Fourier transform, and probability related contents. So first of all, since we want to perform practical based on Z transform, that is a small MATLAB experiment where we are going to calculate the Z transform of the respective input signal, whatever function will be there, and accordingly its inverse Z transform as well. So there are different methods to evaluate inverse Z transform. So standard 3 methods are there, like power series, then residue method, partial fraction expansion method, and all. So here we will be dealing with mainly in the beginning part, that is what do you mean by Z transform in today's session, and then in continuation we will be having discussion related to other aspects of Z transform. Now as all of we know that in time domain analysis purpose, there are different tools and operations available. On the same line for discrete domain, or we call it as the digital domain, also there are some methods. In time domain we have Laplace transform for continuous time systems, for Fourier transform, Fourier series analysis, which gives you analog to digital conversion or decomposition of the signal. That part we have seen. On the same line for discrete time systems, there is a option available, that is Z domain analysis. We are actually switching from time domain to Z domain. The main advantage is that our basic form or the mathematical expression or a model which is available for Fourier transform, Laplace transform is using integration, as well as for Fourier series, whichever coefficient calculation we do, that is also with the help of integration. In case of Z transform, it is made a little bit simpler, that is we have algebraic equation which comprises of summation basically. So, or in other words, we can call it as a kind of a even in the difference equation format also we can express it. So that is going to simplify the analysis of discrete time systems. That is one of the major advantage as far as Z transform is considered. Moreover, in Z domain, the convolution of two time domain signal is equivalent to multiplication of their corresponding Z transforms. So this also is going to simplify the analysis and response related to LTI system, because convolution is treated as backbone for all that analysis, and therefore Z transform is treated as one of the most popular and important tool in case of discrete time analysis. Now this is a simple thing where we have n number of reasons because of which we are going for Z transform. So mostly in the generalized form we have Fourier transform, and it is not going to converge for all sequences. Comparatively, notation is difficult as I mentioned, because it includes integration part, and definitely summation is comparatively less complex, and bring the power of complex variable theory, deal with the discrete time signals and systems. So this is also one advantage which we get with the help of Z transform. So as far as its definition is considered, in the just basic definition, how it is modeled, just see here. So it is a basic equation of a Z transform, where what we have to express our discrete time signal, which is denoted by x of n in general, into Z, into when it is to be transferred into Z domain, then it is expressed with the help of expression, that is x of z is equal to, here you can see, xn z raised to minus n. So this is basic model, or this is, we call it as a analysis equation of Z transform. With the help of this equation we are going to solve. In general, as far as its limits are considered, we are giving minus infinity to plus infinity. Now you can have say for example your signal which is x of n existing for some instance or interval say from 0 to 5, or maybe from some minus to plus. So its occurrence is going to vary as per the respective input signal. So same fashion you are supposed to change here the limits. It is not that always it is minus infinity to infinity. Whatever is your this x of n is providing limits. Same limits are to be assigned here from minus to plus, or maybe from 0 to plus, or maybe from minus to 0, whatever it is coming. In general, whenever it is a causal signal, that is we call it as a unilateral right-sided signal, right-sided sequence. So at that time definitely it will be 0 to some maybe a positive integer, some finite sequence. Conventionally, Z transform is used to analyze finite sequences, where in the deterministic form you will able to get some sort of proper signal interpretation. But no doubt you can use it for infinite sequences as well. It is not mandatory that only finite sequences are permissible, but you can use infinite sequences. So here it is from minus infinity to infinity in general. What is our Fourier transform equation? Actually in discrete Fourier transform form. Here basic Fourier transform is a continuous time equation. It is a continuous time operation which is performed with the help of integration. But here it is with the help of summation, that is its discrete version. So how it is defined? Here z is equal to e raised to minus j omega, and x of e raised to j omega, that is your conventionally we call it as f, x, f and omega. So that is the notation from domain mapping or domain switching when it's carried out. So instead of that, as it is written just e raised to j omega is equal to x of n into e raised to minus j omega n. Now in z plane it is to be mapped. That is the difference. That is as if z transform is what? It is nothing but a Fourier transform, but its evaluation is done in z plane. So that is the difference. So here this is our z plane. Say for example, its x-axis is representing real part, its y-axis is representing imaginary part, and x of z as per definition is your sigma or summation of sequence x of n into z raised to minus n. Now instead of z we are substituting e raised to j omega. So this minus sign as it is, so it is becoming e raised to minus j omega as per definition. It is not derived from anywhere like by adjusting some terms. It is not like that. It is defined. It is a definition of Z transform. It is not derivation of Z transform. So it is defined like this, and e raised to minus j omega n, and this is your Z plane, and this omega is corresponding to angular frequency. So as I told you in a previous class when we were talking about Fourier series, so at that time I mentioned that why we are switching from one time domain, kind of a very simple style we already have, from that time domain to frequency domain. What is main reason? Because in time domain we can't analyze the signal when there is a variation, when there is a real time activity. When there is the real time activity is not or cannot be interpreted using passive elements or passive components, like from electrical or electromagnetic point of view, whatever is happening and which is when expressed in electrical domain or in electrical terms, it is not remaining only resistive, but it is becoming capacitive as well as inductive. And when capacitive or inductive entity comes in picture, or those elements are playing role or they are taking part, automatically you can't keep yourself only in a time domain, because it is not going to show you the variations. It is not going to comment on the effect. It can't give you the actual effect. So it is as if what we say, it is a view. Time domain is a front view, as if say say suppose you can imagine that one thread is there, a long string or a thread is there, and in a wall structure we have say one kind of a pivoting, one screw we have inserted, and there we have tied that knot of that thread or a string, and other end somebody is standing. Say any like children used to play this kind of a game. Somebody is standing and simply keeping the other end of that rope or a string or whatever is a kind of a thread, thick thread, and it is simply moved in free space, just freely. There is no restriction. Like here and there we are allowing that string to move. It is a kind of a wavy effect we are producing. Okay, like the way we observe the waves, like changes are there in the plane, free space, the changes are there. It is not 1D activity. It is not going to remain in one dimension, but it is taking free space. Some sort of ups and downs are observed, and there is a displacement in vertical plane as well as in the horizontal plane. The way you are allowing that string to kind of a dance. छोटे मुलं ते असे रिबन घेऊन उडवायचा खेळ खेळतात ना, तर एका हातानं ती घट्ट धरायचं एक टोक आणि दुसरं टोक तुम्ही फ्री स्पेस मध्ये फिरवताय. So same fashion it is like you are allowing that thread. So whatever those waves or oscillations are produced, that is the another plane. We want to analyze from that point of view. We want to see through. We want to see from as a top view of that. We want to see as a side view of that, profile view. So we are not supposed to limit only front view. So time domain is only front view, and we want to see the effects from other sides as well. So these are the other planes like S plane or Z plane and like that. They are giving you the other say views or the other aspects or attributes of the same mechanism or the same operation. So that is real part. Like frequency is what? Whatever those waves are produced and the way the tips are going up and down and up and down, and whatever is the in between distance, in between variations are observed. Some are low lobe, some are higher side lobes, some are with low amplitude, some are with high amplitude. So all those lobes, they are interpreting your harmonics, and that is nothing but the sinusoidal effect or sinusoidal action. And that action we want to observe, and that is this, what I'm trying to tell you is that is the angular, say, kind of a displacement or a motion involved, and that is interpreted with the help of this omega. Okay, that omega is nothing but again our angular frequency, and angular velocity and angular frequency interrelated. So that particular touch or that approach we want to give, and for that purpose we are doing analysis in some other domain. So this way it is as if what I was trying to tell you, this is your Z plane. So and from that this is a kind of a vector movement or a displacement which is taking place. It is associated with periodicity because it is going to jump, come and down and up and down. So like that. It is a periodic function, isn't it? Because it is going to repeat itself. It is not going to be too random. That is, anything is happening in the beginning, anything is happening in the end. In between, the way it is a kind of a sinusoid propagation, simple harmonic motion kind of a effect. So there is a repetition. So somewhere there is a periodicity associated with it. So that is a periodicness is a property associated with it, and that is like playing very important role. So now we have to come to the basic definition. So where x of z, so given sequence, the set of values of z for which z transform converges. This word plays very important role in the analysis of z transform. What is this converges? Converges is something that relates with its value or its bounded nature, or we call it as a stable nature or stability. Already we studied a system part in the first chapter, signals and system, basic properties of systems. So at that time we stated one property, that is whenever the signal output is bounded one, that is finite one. So at that time we call it as a stable system. So that's why it is stability associated with bounded nature. Now bounded means less than infinity. So in general the area or the space in the z plane where different z values are available. So the area where for the values of z are used or are available such that your final answer, whatever you are calculating after that summation, when we solve that summation, when simplify that summation, and then when we solve it, so after that whatever resultant value we are getting, that value is a constant value. It is a finite value, okay, some number which is finite. So that value is taken as so that particular region or those values for which it is producing finite answer, so that region corresponds to region of convergence. Ask all your friends to join, because I am not here observing almost 50% students. So once again you remind them. You may have your say whatever hurdles or some constraints, but already I told you that your online attendance, and this is for whole class. Now it is not batch wise. So I am supposed to conduct it for the whole class. So all batches students are expected here for attendance. It is not that for only 2 batch or 1 batch. It is not like that. So please inform your friends and ask them to join, because once I will be taking attendance by the end at that time. Otherwise in every class I am telling you to be careful. It is not that because it is online, record is generated, so we by the end if you are requesting or once again you are asking that it was not possible for us and all those reasons, so don't do that. Be there in the class. Ask all of your friends, please join immediately. By the end most of the students are middle somewhere they are coming, so it will be difficult for you to understand. So these are some basic things which in the beginning when I am telling you, so once you remember them or once you understand them, then only it will be possible to solve examples based on Z transform. Okay. Now this is ROC, as a center is origin and the whole plane or the space is available. From that the values for which it is producing finite answers, all those values or all that space is treated as region of convergence. Here you can see. So in general this Z plane is treated as this way. This is a say plane and one circle is shown. Conventionally it is called as a unit circle. So circle with radius 1 is considered as a reference circle. Conventionally, while estimating or while calculating Z transform, one circle as a reference circle with radius 1 is drawn, and then with respect to that is where exactly our say whatever problem we have solved, so those values are lying. On that basis, that is whether they are outside unity circle or inside unity circle, or in the left half or in the right half. So some sort of criteria or say analytical we can call it features are defined, that is based on what exactly where is the region of convergence, in which region it is, whether it is a full excluding origin or whether it is excluding infinity or what. So here one is I have shown. So that may be this way you can draw the circle, and the radius may be Z may be lying in some range, that is Rx plus Rx minus something. So that particular region, that is R, small r, corresponds to the region of lying in the range, its values, all those values are allowed. So that particular space is treated as region of convergence. As I mentioned, stability is the issue here. Stable system requires that its Fourier transform is uniformly convergent. So fact is Fourier transform is to evaluate Z transform on unity circle. So stable system requires the ROC of Z transform to include the unit circle. So whatever I told you, this part, the radius is 1 and this is your unit circle, and your region of convergence must include this unit circle. Okay, we will be solving one small example using MATLAB, because in MATLAB it is ready-made calculation. We need not have to step by step write so many statements and all that. So that part I wanted to show you today. So for that reason I am considering all this basic part at present, because before knowing these things it will not be possible for you to correlate what exactly is happening. So this is related to stability. First part only we are discussing today. So this is, say for example, one small example I have taken. So right sided sequence, say for example it is a raised to n. So some samples are shown, that is here you can see at 0 some value, 0 raised to n, 1 raised to n, 2 raised to n, 3 raised to n, 4 raised to n, like that. Or here one thing you remember, that some samples we are showing at various instants, but how the equation is given, the general sequence. I have not mentioned anywhere any number or a value, actual value I have not mentioned. So only thing is that simple signal is written, x of n is equal to a raised to n u of n. What is a raised to n? Anything. A may take any integer value. For example, we are just assuming that it is a small positive integer, okay, and it's raised to n. Suppose if we start with 0, then 0 raised to n, a is equal to 0. But is it going to produce anything? No, 0. So let it be 1. A is equal to 1 and n is equal to 0, 1, 2, 3, 4, because along n axis, that is x axis, which corresponds to n time axis, we are going to produce these impulses, these samples, that is n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5, and so on. So say a raised to 0, a raised to 1, a raised to 2, a raised to 3, a raised to 4, a raised to 5, like that. So you can have some small number is there, then say 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, like that. Okay. So here what is the say interrelation? Is it rising exponential like this? Is it shown? No. It is shown decaying. So meaning is that your a must be less than 1. Then only it will be decay. Huh? Yes or no? If it is 2 raised to 4, 2 raised to 5, 3, 2 raised to 6, 2 raised to 8, so it will be rising. Yes or no? Anyone? Huh. So if it is a positive number, this sketch is not matching. This sketch is matching when a is not positive but positive integer, whole integer. Then it is not matching. It should be 1 upon something. Then only it will match. What u of n is doing? U of n is saying that its limit is from 0 to infinity. So that's why in this positive half I have shown the signal. Okay. For example, one example we are taking, nothing else. Now here we'll make it clear. So we'll substitute it. Forget about the sketch and what is value of a and all. We don't know what is value of a. Forget. So what we will do? Let it be a only. Let it be. Now we will use the basic definition of x of z. So what x of z is doing here? X of z is equal to sigma a raised to n u of n z raised to minus n. Minus infinity to infinity. Why it is coming z raised to minus n and all? Because this is our definition, and instead of x of n, what is x of n? A raised to n un we are putting. Now because of u of n, see here, two signals are multiplied. One signal is a raised to n, another signal is u of n. So multiplication will exist only when both of them are present. Now as far as a is considered, nothing has been mentioned, whether what is the value of a and all, whether it is positive number, negative number, what, nothing is mentioned. Say for example, let it be present anywhere. So it may take negative values as well as it may take positive values. But remember, since here it is multiplied by u of n, which is our standard unit step signal and which is existing from 0 to infinity with its amplitude always 1. What is u of n or u of t? It is unit step signal whose amplitude is always 1. for existence ideally from 0 to infinity. So because of that, what is happening? This a raised to n will be from 0 to infinity. And what is value of u of n? U of n is always 1. Its value is always 1. So therefore a raised to n only, u of n is 1 into z raised to minus n. So therefore it is 0 to infinity. Now sigma, what we will do is, we want to use some formula related to summation. Already while studying Fourier series, I gave you the list of expressions associated with integration and summation. Formula दिलेत तुम्हाला already. त्यातला summation चा formula we want to use here. So what is that formula? Sigma आपल्याला पाहिजेला आहे alpha raised to n. Okay. If it is less than 1, if it is greater than 1, you have terms. If it is less than 1, आपण लेस दॅन 1 का घेतोय? कारण आपण तिकडे स्केच काढले ना ते मागं. इथे फॉर एक्झाम्पल ते असं डिकेइंग काढले म्हणून आपण अझ्युम काय केलं? a इंटू झेड रेस टू मायनस 1. दिस वन म्हणजे a अपॉन झेड. झेड रेस टू मायनस 1 इज व्हॉट? a अपॉन झेड. होय की नाही? येस और नो? झेड रेस टू मायनस 1 means what? 1 upon z. Isn't it? So therefore it will be a into 1 upon z means a upon z whole raised to n. Now a upon z, if it is less than 1, then your formula is 1 upon 1 minus alpha. Alpha is what? Alpha raised to n. अशी आपण summation चा formula वापरणार आहे. Alpha is a into z raised to minus 1. So therefore 1 upon 1 minus a into z raised to minus 1. So this z raised to minus 1 means a upon z. So z will be LCM. Z will come here and whatever is in the denominator that will just get transferred to numerator. So therefore 1 upon 1 minus a into z minus 1. इथं z into z raised to minus 1 म्हणजेच काय? 1 upon z म्हणजेच a upon z. So denominator is becoming 1 minus a upon z. So आपण त्याचा LCM काय घेतला? z. So z minus a आणि जो divide by z आहे तो गेला कुठं? वर. That is in the numerator. So therefore it is becoming z upon z minus a and z must be greater than a. Okay. Modulus of that value we are calculating. Now if you see this expression, when this expression is going to become infinity? When a is going to become z. Isn't it? A is equal to z. When a is equal to z, denominator will become z minus z. That is 0. That means a should be either less than z or greater than z. But what it should be? Ideally, z must be greater than a. Modulus of z must be greater than a. म्हणजेच तुमचे इथे व्हॅल्यू पॉझिटिव्ह येत राहील काय जे असेल ती. So this way you can draw z upon z minus a. Modulus of z is greater than a. This is unity circle. Somewhere say a is somewhere here, minus a here. See the sketch. You can note it down. Draw this. Because this is giving you the formula also. Z upon z minus a. This is basic formula. I will wait for 1 second. So this is the first one, most popular, a raised to n, un. Now if it is left-sided sequence, you see what is happening. Just see the magic. Carefully see. A raised to n, but it is minus and u of minus n minus 1. What is u of minus n minus 1? How will you draw? Suppose first term. We have studied transformation operation. So first term is minus n minus 1 is equal to 0. Original signal आठवते का? u ऑफ n इज इक्वल टू 0 पासून चालू होणार, इन्फिनिटी पर्यंत असणार. पण आता आपल्याला u ऑफ n काढायचं का? नाही. व्हॉट वी वॉन्ट? u ऑफ मायनस n मायनस 1. सो व्हॉट इज अवर स्टँडर्ड प्रॅक्टिस? whatever is a domain changed term, we are going to equate it with leftmost to rightmost instant, and the new values of time we are going to consider, and then we are going to redraw it. So पहिली व्हॅल्यू काय येणार? मायनस n मायनस 1 is equal to 0. therefore n is equal to, see, listen carefully, minus n minus 1 u of, आपल्याला हा काढायचा आहे, जरा लक्षात घ्या. मायनस n मायनस 1 इज इक्वल टू 0. देन n इज इक्वल टू, मायनस n तिकडे गेलं आणि n इज इक्वल टू काय उरणार आहे? मायनस 1. आता सेकंड केस काय? डिस्क्रीट टाइम आहे. सेकंड केस मध्ये मायनस n मायनस 1 इज इक्वल टू प्लस 1. देअरफॉर n इज इक्वल टू, मायनस n तिकडे गेला आणि हा 1 आहे तो इकडे आला मायनस 1, म्हणजे मायनस 1 झाला. त्यामुळे n इज इक्वल टू, पेपरवर करून बघा, ज्यांच्या जवळ वही पेन जवळ आहे. सो यू कॅन राईट डाऊन मायनस n मायनस 1 इज इक्वल टू 1. देन व्हॉट इज n? एनीबडी टेल मी. मायनस n मायनस 1 इज इक्वल टू 1. व्हॉट इज n? अनम्यूट करून आन्सर करा. सिंपल गोष्ट सांगितली आहे. हा, मायनस 2. ओके, सेम फॅशन, मायनस n मायनस 1 इज इक्वल टू नाउ 2. देन n विल बिकम मायनस 3. मायनस n मायनस 1 इज इक्वल टू 3. तर n इज इक्वल टू मायनस 4. सो लाईक दॅट मीन्स sequentially it will become minus 1, minus 2, minus 3, minus 4 and so on. Okay. One more thing. A raised to n but with minus sign. So this minus sign is indicating that all the samples will be negative in the amplitude. So ते सगळे मायनस काढले आणि अजून एक काय केलं तर ते डीके होणार आहेत. मगाशी कसे असे इकडून आपले असे डीके झाले ते पहिल्या ग्राफ मध्ये, आता असे डीके होणार आहेत. सो a raised to n, a is less than से कमी म्हणजे मायनस 1 ला सगळ्यात हायेस्ट, मग 1 अपॉन आहे ना ते करंट, मग 1 अपॉन a स्क्वेअर, 1 अपॉन a raised to 3, 1 अपॉन a raised to 4 असं करत ते कमी होत जाणार. डिनॉमिनेटर वाढत जाणार, टोटल आन्सर कमी होत जाणार. सो देअरफॉर दिस इज अ डिकेइंग काइंड ऑफ पॉवर सिक्वेन्स. इट इज अ series or sequence of a raised to n terms. n is equal to 1, 2, 3, 4 like that. So because of u of minus n minus 1 ना त्याला मल्टिप्लाय केलंय आपण. इथे मल्टिप्लाय केल्यामुळं all the values are coming in the negative half. Now we will solve it for Z transform. You can take screenshot or you can note down. This is very unique standard problem आहे. हे दोन्ही प्रॉब्लेम पेपर मध्ये मोस्ट ऑफ द वेळा ओरलला, पेपरला, गेट एक्झामला सगळीकडे पडतात. कुठे पडत नाहीत असं नाही. सो झेड ट्रान्सफॉर्म यू हॅव व्हेरी पॉप्युलर काइंड ऑफ से mathematical operation in digital signal processing, in image processing, everywhere it is used. So now see here how it is substituted and how it is solved. Minus sign will keep outside. Sigma a raised to n u of minus n minus 1 multiplied by z raised to minus n. Minus sign as it is, a of raised to n as it is, u of minus n minus 1 च्या बदली त्याचे आन्सर काय असणार आहे? 1च असणार आहे. सो 1 इंटू z raised to minus n. फक्त लिमिट बदलायचे. लिमिट काय आहे तर आपण माझा सिग्नल बघितला. लिमिट आहेत मायनस इन्फिनिटी टू मायनस 1. आता लोअर लिमिट टू अप्पर लिमिट आहे, त्यामुळे उलट लिहायचं नाही. मोस्ट ऑफ द टाइम्स मोस्ट ऑफ द स्टुडंट्स यूज टू राईट लाईक लोअर लिमिट इज मायनस 1, अप्पर लिमिट इज मायनस इन्फिनिटी. सी मायनस व्हॅल्यू बद्दल बोलतोय. मायनस व्हॅल्यू आपण मायनस इन्फिनिटी कडे जाईल कशी? नंबर जरी मोठा दिसला तरी रिझल्टंट व्हॅल्यू इज गोइंग टू गेट रिड्यूस्ड, कमी होत जाणार ना ती. त्यामुळे त्याची लोएस्ट व्हॅल्यू इज मायनस 1, हायेस्ट व्हॅल्यू इज लोएस्ट व्हॅल्यू इज मायनस इन्फिनिटी, हायेस्ट व्हॅल्यू इज मायनस 1. So minus infinity to minus 1. Now what we will do is we will change. This is n. Domain काय आहे या सिग्माचा n आहे. जसा इंटिग्रेशनचा डोमेन असतो तसा सिग्माचा डोमेन काय आहे, n आहे. सो विथ रिस्पेक्ट टू दॅट वी हॅव मायनस मायनस, लोअर लिमिट इज ऑल्सो मायनस, अपर लिमिट इज मायनस. सो आपण साइन चेंज करू शकतो की नाही, करू शकतो. सो व्हॉट इट इज, n is equal to, now we are changing the sign. So earlier here it was a raised to n, that will become a raised to minus n, and here we will make plus 1 to plus infinity. Okay, so this is 1 to infinity, and now we will simplify it. Now a raised to minus n, just see here one thing very carefully. N is equal to 1. We have summation formula for 0 to infinity, but we are having now at present 1 to infinity, means one term is missing because n is equal to 0 term is missing. We can apply the basic formula from our summation theory only when we have sigma from 0 to infinity, but here at present sigma is from 1 to infinity. So what is 0? N is equal to 0. What is a raised to 0? 1. So that one we will add here. Okay, and here we will make limit 0 to infinity. समजतंय का काय केलं? 1 to infinity आहे, त्याच्याऐवजी आपल्याला इथं 0 to infinity घ्यायचंय. इथं 0 to infinity घ्यायचंय म्हणजेच आपल्याला एक एक्स्ट्रा टर्म हवी आहे जी n is equal to 0 ची आहे. n is equal to 0 ला टर्म काय असणार आहे? n is equal to 0 म्हणजे z raised to 0 1च असणार, a raised to 0 पण 1च असणार, म्हणजेच काय 1 असणार आहे. तर तो 1 आपल्याला इथं घ्यायचा आहे. सो फॉर दॅट पर्पज व्हॉट वी आर डुईंग, तो 1 आपण इथं घेतला, तो 1 आपल्याला मायनस झाला, मायनस मायनस, आता इथे 1 घेतला ना तो, सो 1 मायनस इथे 0 टू इन्फिनिटी. म्हणजे ही टर्म काय आहे तर ती एक जे टर्म त्यात नाहीये, दॅट एक्स्ट्रा टर्म वी हॅव टेकन हियर, अँड देअरफॉर वी हॅव चेंज द लिमिट. आता लिमिट चेंज केल्यामुळे काय होणार आहे सांगा, इथं 0 घेतलं की ए 1 मायनस, समजा यातली आपण 0 वाली टर्म बाहेर काढली तर ए रेस टू 0 ची टर्म बाहेर काढल्यावर 1 ती 0च असणार, ए रेस टू 0 केल्यावर 1 असणार आहे ना. सो 1 मायनस 1 ती 0 होणार, म्हणजे परत आहे तसं हे ओरिजिनल मायनस ऑफ सिग्मा होणार आहे. म्हणजेच काय, आपल्याला 1 ऍड आणि 1 सबट्रॅक्ट करायचे. 1 जे ऍड केलं ते इथं लिहून घेतलं, आणि जे सबट्रॅक्ट करायचे ते कुठं घातलं, 0 इथे लिमिट चेंज केलं. 0 लिमिट चेंज केल्यामुळे इथे एक्स्ट्रा टर्म आली, ती ऑटोमॅटिकली जर ते एक्सपांड केलं तर ते कॅन्सल होणार आहे. सो देअरफॉर हिअर ॲज इफ, कळतंय का, लक्षात आलं का काय केलं ते ऑल ऑफ यू. 1 टू इन्फिनिटी लिमिट आहे, त्याच्या बदली इथं केलं 0 टू इन्फिनिटी. मग 0 टू इन्फिनिटी केल्यामुळे ह्याच्यामध्ये काय व्हायला लागलंय, जी ऑलरेडी आपली 1 टू इन्फिनिटीच्या समजा इन्फिनिटी टर्म्स आहेत, तर त्याच्यामध्ये आणखीन एक टर्म ऍड व्हायला लागली आहे n इक्वल टू 0 ची. जी ऍड व्हायला लागली आहे ती आपल्याला वजा करायला पाहिजे. याचा अर्थ ऑलरेडी इथं मायनस साईन आहे, त्यामुळे यातनं जी टर्म येणार आहे ती नुसतीच उरणार आहे. मग तिला आपल्याला घालवायची आहे, पण ती ऑलरेडी मायनस आहे, म्हणजेच तिला ऍड काय करायला पाहिजे, प्लस टर्म मध्ये ऍड करायला पाहिजे. प्लस टर्म त्याची व्हॅल्यू सेमच असेल. ए रेस टू 0 ची व्हॅल्यू काय आहे, 1 आहे. झेड रेस टू 0 ची व्हॅल्यू काय आहे, 1 आहे. म्हणजे जर n इक्वल टू 0 असेल तर या सिग्माचं पहिली टर्म 0 ची असणार आहे, ती काय येणार आहे, 1 येणार आहे. ते 1 आणि हे 1 कॅन्सल होणार की नाही, आणि उरलेला सिग्मा तसाच राहणार की नाही. सो देअरफॉर ओनली वी हॅव रिअरेंज्ड. हे रिअरेंजमेंट का केली आपण, कारण आपल्याकडं फॉर्म्युला सिग्मा 1 टू इन्फिनिटीचा नाहीये. फॉर्म्युला वी हॅव सिग्मा 0 टू इन्फिनिटी अल्फा रेस टू n. सो वी वॉन्ट टू यूज दॅट फॉर्म्युला. आपण अर्लियरच्या एक्झाम्पल मध्ये पण वापरला की नाही, सेम फॉर्म्युला वी वॉन्ट टू यूज. सो 1 अपॉन 1 मायनस अल्फा, दॅट इज अ फॉर्म्युला. सो 1 अपॉन 1 मायनस अल्फा पाहिजेल आहे, तेव्हा आपला सिग्मा अल्फा 0 टू n इन्फिनिटी साठी अल्फा रेस टू n and n is equal to 0 to infinity पाहिजे. So alpha is this term, all this a raised to minus 1 into z. Okay, so here we will write a raised to minus 1 into z. नीट बघा, एकदा बेसिक गोष्टी आहेत, अगदी summation basic part is there. It is not very complex or complicated, only rearrangement of terms and simple rules related to summation theory we are applying. कळलं का? सो इथे घेतला आपण a इंटू रेस टू मायनस 1 इंटू झेड होल ब्रॅकेट रेस टू n अँड 1 मायनस ॲज इट इज. सो इथे पण सेम कॉन्व्हर्जन्सचा रूल आहे, फक्त व्हॉट इज द डिफरन्स, अर्लियर हिअर इट वॉज a रेस टू a होता, इथे आपला आणि z रेस टू मायनस 1. आता इथे आपला काय झालाय, आपण हे मायनस साइन घालवले ना, हे मायनस साइन दिल्यामुळे, मायनस लिमिट कॅन्सल केल्यामुळं, मग हे मायनस साइन गेल्यामुळे आपल्याला इथं झेडची पॉवर काय झाली आहे, प्लस झाली आहे. सो देअरफॉर आपला कॉन्व्हर्जन्स काय असणार आहे, a⁻⁻1 into z less than 1. So therefore z is less than a. In the previous case, when it was u of n, at that time we got z must be greater than a. And when it is in negative half or it is left sided, so it is becoming z is less than a. Understood? So now we will write the terms. 1 minus sigma a⁻⁻1 into z whole bracket raised to n is equal to 0 to infinity. So 1 minus 1 upon 1 minus a⁻⁻1 into z, which is equal to z upon z minus a. Okay, one thing you remember here and one thing you observe also, in both cases your answer of x of z is z upon z minus a only. The only thing what is changing is region of convergence. In the previous example, when it was not minus sign, only a⁻n u of n असं होतं, त्यावेळेला region of convergence was z greater than a, and now it is z less than a. This is very important because this term we want less than infinity. This is only possible when a⁻⁻1 into z is less than infinity. Because if here we put z is equal to a, then the answer will become 0 and denominator will become 0, and therefore your x of z answer will become infinity, and which will not converge. For z transform we want our answer must be finite one, it should converge, and we want to determine the values of z for which it is converging. We don't want divergence by any means in this case. Getting? So this is the effect earlier that unit circle include होतं. आता बघा इथं कसं दिसतंय, हा तुमचा z आहे a वाला आणि इकडे सर्कल. सो रिजन ऑफ कॉन्व्हर्जन्स त्याच्या बाहेर आणि इथं आला तो त्याच्या आत. सो दॅट इज द डिफरन्स. z मस्ट बी लेस दॅन a. सपोज इफ दिस इज द a लिमिट, इट शुड बी लेस दॅन दॅट. सो ते आत आहे, समजून घ्या, बाहेर नाहीये, आत आहे. ओके, मगाशी ते बाहेर होतं, आता आत आहे. सो दॅट इज द डिफरन्स. इनर साइड, आउटर साइड. सो फॉर लेफ्ट साइडेड सिक्वेन्स it is inside. For right sided sequence it is outside. That is the exterior part of unit circle, and this is interior part of unit circle. So this you have to remember. One slide, it is related to representation for rational function. So here I will write x of z is equal to, in general it is expressed with the help of say terms are there which are in terms of z. So it may be having numerator and denominator. Why I'm telling this part, because in practical also we want to draw polar plot of the same. म्हणजे एक experiment आपण घेतोय where we are going to draw the poles and zeros from the given expression. So for that purpose, just in this beginning session I am adding this particular. So it is p of z divided by q of z. So where p of z and q of z are polynomials, and zeros corresponds to x of z 0, the values of z such that x of z will become 0, and poles are corresponding to the values of z such that denominator, that is x of z, will become infinity. So this is the rule for poles and zeros as far as z transform is considered. So this is your a⁻n u of n and right sided sequence. So that is ROC. It is bounded by pole and it is exterior of the circle. मगाशी मी जे सांगितलं, that we are again just summarizing it. Then left sided of sequence, ROC is bounded by the pole and it is interior of the circle. So this is boundary condition is pole. So which is in just a small value which is less than z value is less than a, and therefore it is interior of that circle whose radius is a. So that is its region of convergence. Now say for example one more signal. We'll be using general formula, and from that we can write. Now see here, if there are two terms, what is happening? So one is a raised to n u of n. This is also a raised to n u of n. But here a is 1 by 2. Here a is minus 1 by 3. What is our Z transform formula? A raised to n. Now as a outcome of this lecture, permanently लॉक किया जाए तुझ्या तुम्ही लक्षात ठेवा कायमचं काय a raised to n u of n. What is its Z transform? Z upon Z minus a. Remember, a raised to n u of n. Z transform is Z upon Z minus a. Now say for example 1/2 raised to n. So what is a? 1/2. So therefore what will be its Z transform? Z upon Z minus a. So a is 1/2 plus second term. What will be Z transform? Minus 1 by 3 raised to n. So Z upon Z minus 1 by 3. So therefore it is minus plus. So you can simplify this one. LCM you can write Z minus 1 by 2, Z plus 1 by 3, and then multiply here. Rewrite the terms. Little bit simplification. So it is coming something like this. So don't worry about numerator part. Let it be whatever. Our main interest is in denominator, because that is going to condition our Z transform. So because the region of convergence is related to that, therefore it is to be ruled by that. Please note down this, or you can take screenshot. I will wait for 1 or 2 seconds. So please note down. Okay, fine. So this is your poles. This is your pole 0 diagram. Z plane. Poles are indicated using cross sign. Zeros are indicated using circle. So it is at Z minus 1 upon 12. This is 1 0. Another one is Z is equal to 0. So origin ला एक है. So एक छोटासा blue circle, whatever is you are just seeing, visible. Okay, 2 blue circles, small circles. One circle is because of this Z. So 1 0 is at Z is equal to 0, and another 0 is Z equal to 1 upon 12. How we have defined poles and zeros? Zeros means what? The numerator polynomial values of Z for which this numerator is becoming 0. And what are the poles? Values of Z for which denominator is becoming 0. So here Z is equal to 0 ला पण 0 होणार आहे. Z is equal to 1 by 12 also giving you 0. So therefore there are 2 zeros. And what are the poles? Poles are Z is equal to 1 by 2 केलं तरी पण ही टर्म 0 होणार आहे. Z equal to minus 1 by 3 केलं की ही टर्म 0 होणार आहे. आणि डिनॉमिनेटर मधली कुठलीही टर्म जरी 0 झाली तरी तुमचा रिझल्टंट जो x of z आहे तो इन्फिनिटी होणार आहे. So what is pole? Value of z in the denominator because of which x of z is becoming infinity. And what is 0? Value of z in the numerator because of which x of z is becoming 0. So values of z for this problem, z is equal to 0 and z is equal to 1 by 12. Both of them are giving you zeros of this signal, and 1 by 2 and minus 1 by 3, these are the two poles. One pole is positive pole, another pole is negative pole. So on the axis randomly the locations are shown, that is 1 by 2 and minus 1 by 3. Fine. See here one more. So this is minus 1 by 3 raised to n u of n minus 1 by 2 raised to n u of minus n minus 1. Answer is same. The only thing is that the boundary conditions are different. You have to show it differently. Z less than A is the condition for this. Because otherwise expression is the same. Z upon Z minus A, minus is minus 1 by 3. Z upon Z minus A only, minus 1 by 2. Here only condition is because of this u of minus n minus 1, this is going to become for Z less than A. So Z less than A is Z less than 1 by 2. And another one is for Z greater than. But this is also with minus n. So therefore one pole is at plus 1 by 2. Another pole is at minus 1 by 3. Both zeros are at 0 and 1 by 12. But region of convergence is in between. Unity circle wise speaking. Understood? Does not include any pole. So it is not including. Region of convergence is inside that. This part. Boundary conditions length. One more you can see here. These are the ROC. So 0 to n minus 1. So 0 to n minus 1. Earlier example we consider it as infinity, but it may be not necessarily always infinity. Some finite number may be there. So that is 0 to n minus 1. And for that formula is 1 up minus alpha raised to n divided by 1 minus alpha. So little bit simplification you can see here. And the region of convergence will be again this in this plane your terms. See here, we don't know the value of n. So at actual we can't draw. But tentatively the sketch or the way it looks. So that also only we have shown. So this is the way. As far as ROC is considered, you are supposed to remember these basic properties of ROCs. First thing is the ring or a disc in the Z plane centered at the origin. So this is mainly indicating the ROC. The Fourier transform of x of n is converge absolutely. It is a convergent, spelling mistake, if the ROC include the unit circle. ROC cannot include any pole. Finite duration sequences, the ROC is entire Z plane except possibly Z is equal to 0 and Z is equal to infinity. For right sided sequence, ROC extends outward from outermost finite pole in x of Z to Z equal to infinity. And for left side sequences, the ROC extends inward from the innermost non-zero pole in x of Z to Z is equal to 0. So these are some of the properties which we can use while studying this. This way you can have. Okay. Now we will see this in MATLAB how to do. Is it okay? So in MATLAB we can do it. For that there is a ready-made function available, ztrans, Z-T-R-A-N-S. So that is the function. Now see the program. I will wait for a moment. Actually, I want to show you Z transform and inverse Z transform program and output. So for that you should know whatever exactly the basic part. So that's why today we have considered it, and already we were in position to start that 4th chapter as well. So that in this week we will make Z transform, inverse Z transform, and afterwards Laplace and Fourier. Once you know only it is interrelated. Any one transform, once you know how to, because in MATLAB also it's very easy, because already we have done Laplace, LS and ILS. So that is ready-made functions are there. In Z transform also you have for Z transform and for IZT. Both way there are ready-made functions. Even for IZT, for residue calculation also there is a separate function. For partial fraction also there is not one-to-one but close function which we can apply, and we can get the partial fractions. That is useful for Laplace transform as well, because that partial fraction part is here as well as in the Z transform and Laplace transform. Inverse calculation in both it is available. So here you see. So in the beginning what you are supposed to do is, this is as I mentioned that in the earlier program which we did, 5-6 programs we already done. So in that plotting program which was done where different signals we have done that experiment. So in that it was shown same fashion here, SYMS, that is system defined whichever variable you want, so that you have to take. So say for example n, it is real, it is a integer or a real whole number, it is not a complex number basically that you have to mention. So that's why I mentioned it is real, and I want to calculate, say for example my a is less than 1, then I can directly get the transform in the form of z upon z minus a. So therefore I am taking here 0.5, any value, that is 1/2, as if, which we consider in those PPTs. So same fashion here it is 0.5, instead of 1/2 I am writing 0.5 raised to n. So in MATLAB this is raised to. So this is my signal, x1 is equal to 0.5 raised to n, and now I want to display the answer. So for that purpose I have used function DISP from MATLAB. So this is our 16 release MATLAB version. In our college also we have the license version for this, as well as even the most recent 1920. So that release is also available in your PL3 lab. So when you all will be in the college, you please use it for signal systems, for image processing, for DSP. It's very effective tool. Already I mentioned in our first practical. So same fashion for Z transform, Laplace transform, Fourier transform, DFT, filter design. For all these we can use. Very simple and very small. See here, DISP, and I have written here that what exactly is I want to print. So I want to print that the Z transform 0.5 raised to n is. So this message I want, and then the answer. So in front of that it will show you the answer. X1 is equal to ZTRANS of x1. X1 is written here 0.5 raised to n, that is a raised to n. Same fashion one more I have written here, so that two answers will get. X2 is equal to 1 plus n into 0.5 raised to n minus 1 something, because I want to show you the shifting property and all that. But at present, since that part still we have not studied, that is properties of Z transform, properties of Fourier transform we have studied. Same fashion properties of Fourier series we did. Similarly, there are properties associated with Z transform, Laplace transform and Fourier transform. It is a time shifting property, scaling property. So same thing, derivative property. So that's why we have I have directly used the expression, and this directly will give you Z transform. While solving those examples, we will consider this, but at present in MATLAB it is giving you ready-made. So this is our program. Simply run that. Me, it's taking some time. Just a moment. It will show you. So this is the answer. Just you can see here. I executed 2-3 times I have done. So therefore those many times it is showing you. Forget here you can. So this is our first one. This one which we studied, a raised to n. Z transform of 0.5 u raised to n is. So it is z upon z minus a. So here a is 0.5 means 1 by 2. So this is your answer. Now here it is z transform of 0.4 into n minus 1 raised to n minus 1. So accordingly it is giving you the z transform. On paper also you can try and solve that. Okay. Simple one. Here is also one more. Inverse. So I have taken 1 upon z raised to minus 1, 1 minus z raised to, whatever you want you can take it. So like that some expression I have taken. The only difference is in the beginning this clear screen, close all, clear all, system variables n and z I have used. One expression I have given here. Any expression whatever you want you can give. So display message I have given, and x is equal to inverse z transform of, and you have to pass the argument x, z and n. That is the difference. In case of previous example you have to pass for z trans only whatever is your variable of which you are solving or calculating the z transform. But here all the three and simplify. So that in the little bit simplified form it will give you the answer. Wait for a minute, it will show you the answer. So this inverse z transform is n by 2 plus minus 1 raised to n by 4 plus 3 by 4. Anything you can do. So this is also one more I have done. 2z divided by 2 into z minus 1. So like that. And directly I will put here expression. One polynomial. 4z divided by 4 into z minus 1 minus z raised to minus 1 plus 5, and this is divided by some pole 0 kind of a thing I have done, and inverse z transform. This also will give you the answer. These are direct answers. 1/2 raised to n. See here 2z divided by 2 into z minus 1. So that is z upon z minus 1, but it is divided by 2. Okay, so that way also it can show you. So this is something which you can deal with z transform. This one is fine. So even we can add here 1, 2, 3 expressions whatever, and accordingly we can get the z transform of that. Only thing you have to remember is the function name, z trans, z trans, that is the key. And in the declaration part this system variables you have to mention. So whichever variables you want. Here I want only n, then only it can understand what is that n, that is that particular system application specific notation or mnemonic of that. So that you have to understand. Okay. So we will, the same fashion we will do for Laplace transform. Already we have done, and IZT, one more method we will see. So at present for this session this is okay. Just a moment.